Good evening. Thanks for sticking around. My name is Robert Lillianfeld. Today I'll be talking about the work we've been doing in Jean Herman's lab on experimental observations of geometric phases in mesoscopic narrow-gap semiconductor systems. We use two different types of semiconductor systems in our work. We use an indium arsenide heterostructure system and an indium antimonide heterostructure system. In the indium arsenide system, we observe an Aharonov-Bohm phase, an Altshuler-Aharonov-Spivak, or AAS phase, and a Rashba spin-orbit interaction-based Berries phase. In the indium antimonide systems, we see an AAS phase and time-reversal Aharonov-Kasher phase. Here we see magnetoresistance data from a 7x7 ring array with rings 350 nanometers in radius and a conducting width of 130 nanometers. We see at low fields high-frequency AAS oscillations, at higher fields Aharonov-Bohm oscillations, and the beating is the evidence of our geometric spin-orbit interaction. We can separate out our h over 2e and h over e components from our magnetoresistance data, that we see high amplitude oscillations that die out at higher field values indicates Altshuler-Aharonov-Spivak interference, which is due to Aharonov-Bohm interference between time-reverse pairs. Furthermore, the different functional dependencies in h over e and h over 2e temperature dependencies further indicates different physical mechanisms underlying these two oscillations. Major feature of our Fourier transformations is a strong splitting in our Aharonov-Bohm peak. This is believed to relate to the intrinsic magnetic field of spin-orbit interaction. When we calculate the intrinsic magnetic field through Shubnikov-de-Haas oscillations, we find a discrepancy between that and our calculated value from splitting, a factor of roughly 40. This has been observed by other groups as well. This is a common problem. We believe this is due to the non-adiabatic nature of our transport. If we make a simulation with a dynamical phase, we see a relatively good qualitative fit with our data as opposed to a simulation with no dynamical phase. We also observe a Aharonov-Kasher phase in a modulation of the AAS amplitudes in our indium antimonide samples. Thank you very much for your time.